In section 1.6, we learned about functions and about how every x could only have one y, right? But functions are a really important idea. They're basically all we work with in this course. So that said, we're going to have a special notation for them. The dependent variable, which whenever you see dependent variable, you can think to yourself, y, right? That's what it is. There you go. So dependent variable is a fancier word for y. Okay, so you're going to take that dependent variable, and I'm putting y in quotes, of course, because we don't always actually use the letter y, but you get the general idea. Okay, so that dependent variable of a function can be represented with the letter y or the letter t or p or whatever it is they give you, or you can write it this way by writing the independent variable name within the parentheses. That's kind of the more fancy way to do it. And it's useful because you're going to have times where you're going to have multiple functions at once. And so this notation is really handy. To give you a hint, when I teach calculus, for example, or pre-calculus, all I ever do is f of x. And that's what we say, f of, that's not timesing, that's of, f of x. Right? Parentheses are this weird object in mathematics. Parentheses mean times, but they also mean a lot of other things, like everything that goes on inside of it. Substitution, you use parentheses whenever you substitute a negative value, etc. So in this case, this is not a timesing. It's not f times x. It's f of x. All right, so you're going to evaluate f of x equals 3x minus 5. Now remember, this whole f of x thing just means that it's a fancier way of writing y. Right? So what you want is you want to say, okay, y equals f of x. That's what I'm asking you, right? All right. Down here, I'm asking you for f of 4. Now, look at the thing up here. F of x. Do you see how the x is inside the parentheses? Inside the parentheses is your independent variable, your x. In this case, x is inside that parentheses and x is over here. So it's 3x minus 5. So this is the machine. Remember in chapter 1 we talked about how functions sort of like a machine, sort of like a microwave, a box into which you stuff. Here's your box, here's your machine, and you're going to take x's into it, you're going to stuff them in, you're going to do this to it, multiply by 3 and subtract 5, and then you're going to get out your y. So I'm telling you with this little notation here that what I want you to do is that I want you to take f of x, and I want you to write, instead of 3 times x minus 5, matter of fact, let me write that. There's your f of x. That was the equation that was given. I want you to find f of 4. So you can see what I did was I lost the x and I put in 4. So that means over here in the equation, I'm going to lose the x and put in 4. Right? Where there was an x becomes 4. And then you just find it. That's 12 minus 5, which means it's 7. Done. So a way you could say this is that when x equals 4, y equals 7. And what I was looking for was the 7 part. Right? That's just for your own notes. That's not really, the answer to the question. The answer to the question is 7. Alpha 4 equals 7, period. But this is what's happening. When x is 4, y is 7. All right, what about the next one? Negative a third. So it says f of negative a third. So instead of writing f of 4, I'm going to write f of negative 1/3. So instead of 3 times 4, I'm going to write 3 times negative 1/3. Where there was an x, I get to put in whatever's inside that parentheses. All right, so that's equal to 3 times negative a third. This part right here is equal to negative 1 minus 5, which means negative 6. So negative 6 is my answer. So when you have the variable in the parentheses, right, when x is negative a third, y is question mark, because that's what I'm asking. So when x is negative 1/3, y is equal to negative 6. All right, now what about c? Well, let's see here. Well, it's going to be not really much more complicated. It's just a little bit more annoying. I'm going to have to take a plus 3 and put that in. Okay, so where there was an x, I'm now putting a plus 3. So 3 parentheses a plus 3, like that. Oh, a minus 3. A minus 3? Hold on, let me double check. Oops, a minus 3. All right, hold on. A minus 3. Right. So I'm going to do 3 times a minus 3 minus 5. And then we would just kind of clean that up a little bit. That's 3a minus 9, because you got to distribute 3 times a, 3 times negative 3. So 3a minus 9 minus 5, which is 3a minus 14. There's your final answer. Done. Now D is a little bit trickier. I'm not asking the same question in D. Now if you look at A, B, and C, do you see how they have the number in the parentheses, number in the parentheses? Well, whatever it is, but it's in the parentheses. So for A, B, and C, I gave you the x value, right? So x is equal to a minus 3, y is equal to 3a minus 14, right? I gave you the x and I was asking for y. Now here, I want you to find the x when f of x equals 10. Now you can see the 10 is not in that parentheses. I'm not doing the same thing I was doing for A, B, and C. A, B, and C, you put 10 in the parentheses, so 10 goes in for x. But for D, 10 is outside the parentheses. So I'm asking you when y is equal to 10, x is equal to, that's what I'm looking for. So I'm going to take my equation. I'm going to say, okay, f of x equals 3x minus 5, right? And then they said they wanted f of x, this whole thing, to be equal to 10. So I say 10 equals 3x minus 5. I'm not putting 10 in for x. The 10 isn't inside the parentheses. That's what it was for A and B and C. The 10 is outside. It said equal to. So I take the whole thing and set it equal to 10. Then you add 5 to both sides. You're going to get 15 equals 3x. Divide by 3. If you do it to the right, you got to do it to the left. So x is equal to 5. Okay. So if you like, here's what's happening. This one, if students always want to know, oh, how do you write this? So for this one, I could say f of 4 is equal to 7. That's actually what I was asking. F of 4 is 7. Independent is 4, dependent is 7. This one, I could say f of negative 1/3 is equal to negative 6. That's my actual answer, right? When the x was negative 1/3, my y was negative 6. Done. Okay. This one, I'm really asking f of what is equal to 10, right? So I found f of 5 is equal to 10, right? 5 was the answer part that I was looking for. Oh, that's a good way to do it here. So up here, I wasn't really looking for all of this in the box. Let me put it this way. What I was looking for was just the 7 part. Right? The 7 part was the part that I was searching for. That's my answer. Okay? And then down here, let's see, f of a minus 3 is equal to, that's the part I'm looking for. And then over here, the part that I was really looking for was that negative 6 part. Okay? So f of negative 1/3 equals negative 6. So the boxed parts are the parts of what I was searching for. On this one, the boxed part that I was searching for is actually inside, right? I didn't know what x was. I just knew that the whole thing was equal to 10, so I knew y was 10. So when when y is 10, x is 5. All right, now what about the next question? Evaluate g of x at x equals negative 2. Right? Don't forget PEMDAS. PEMDAS is please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. It's called the order of operations. You have to follow them. All right. So what I'm looking for here is really g of negative 2, right? So they didn't write it that way, but that's what they're asking for. X is negative 2. So instead of, here, let me write it down. Instead of x, I'm going to write the number negative 2. Okay, so here instead of x, I'm going to write negative 2, and here I'm going to write negative 2. It's called substitution, right? I'm putting in negative 2 wherever there was an x. Now here's where the please excuse my dear Aunt Sally part comes in handy. You have to do exponents before you can do timesing. There's no parentheses in here. Parentheses means if there was something in here like 5 plus 2, then you'd have to do that. But we don't have anything inside to do. We do, however, have to deal with this squaring. So it's 3 times 4 plus 8. Now, where am I getting the 4 from? Negative 2 times negative 2 is positive 4, because when you square a negative like that, you turn it positive. So this is 12 plus 8, which is 20. There you go. All right, now everything doesn't have to be in an algebraic form. Algebraic form means I've got this fancy equation with x's and y's and g of x's and all that stuff. You don't have to do it that way. You can also figure it out from a table. That's called numerically. So if we look at this table here, they want us to find f of 5. Now let's just make a note to ourselves. This y over here is equal to f of x, right? Has to be, because that's our function. All right, so if they want f parentheses 5, what they're really telling you is, hey, x is 5. So let me make a note. X is 5, y equals question mark, right? That's what they're asking you for. So you go to the table where x was 5, and you say, oh, the y value there is 16. So my answer is 16. I'm going to box it. So I always try to box all my algebra answers. So 16 is the answer. When x was 5, y was 16. Let me give it a little bucket. Okay. That's that one. All right, now letter B wants to know about when x is, or excuse me, find x when f of x is 13. Ah, it's a different problem. I didn't put the 13 inside the parentheses. I put the 13 over here, which means I'm talking about this one. I'm saying when y is 13, x is equal to what? That's what I'm asking you. I don't come right out and say it, but that's what I'm asking. So how do you do that? Well, you say, okay, f of 2 is equal to 13. So that's my answer, right? 2. So I guess I could just say x equals 2. That's the answer. Oh. So they have you saying, hey, you know, when x is 5, y is what? Right? Because I gave you the 5 to start with. So I'm looking at this one. When x is 5, y is 16. And then for the other one, I'm giving you the 13 to start with. That's a y value. And I'm asking you for the x, right? So it's got to be 2 because when y is 13, x is equal to 2. All right, now what about the intercepts? Let's see if we can find those. Oh, but we're going to have to do it in the next problem because, or the next video because we're out of time on this one. So I'll see you back here then.